Hi, my name is Dong J. Lee, and I would like to present Physics Lab 2 on motion of falling object. First, the objectives of the experiment were to observe object motion under constant acceleration, and second, understand that the constant acceleration in free falling motion stems from the gravitational force of 9.8 newtons. Third, be able to determine the difference between motion with and without the drag. And lastly, generate a computational model and graph of both motions and be able to provide a visual data of the difference. Analyzing this experiment using Newton's second law, object falling without drag force is only affected by the gravitational force of 9.8 newtons, whereas object falling with the drag force is affected by both the gravitational force of 9.8 newtons and the drag force of air resistance that counteracts the g-force in this case alone. This combination of force creates something called terminal velocity. So here is a brief footage of the clip from the actual experiment where I dropped the ball of mass 0.02 kilogram from 1.74 meters above the ground. Using tracker software, I edited the video so that it was easier to analyze. After analyzing the video on tracker, I was able to find both the graph and data table of the relationship between time and position of the ball. To compare this experimental data with the computational data generated by Python, I have generated two separate codes. The first code consisted of an ideal case where drag constant b was 0. The second code consisted of a realistic case that would resemble experimental data gained from tracker, since the code consisted of a drag constant of 0.013. When all three data were expressed in a single graph, it became clear that under the ideal situation where drag force does not exist, the ball would travel further as expressed by the blue dotted line. However, the time it took was identical to the ones with the air drag. The time it took was 0.6 seconds. The experimental data extracted from the tracker, which is expressed in green, displayed very similar match to the theoretical data extracted from Python under air drag, which is expressed in red. According to the graph, it is clear that these two lines resemble each other because they both represent the realistic situation where the drag force comes into play. This answers the question regarding whether which model would predict the terminal velocity better. Since the model without the drag force does not have terminal velocity due to constant increase in velocity, the model with the drag is more appropriate for predicting terminal velocity, since the drag limits the velocity from constantly increasing. In other words, horizontal asymptote being present in velocity versus time graph of drag present situation, the graph that takes drag force into consideration is more suitable in predicting terminal velocity of the ball. If the object is thrown with an initial velocity, the terminal velocity would still be the same. The only difference is that the time it takes to reach the terminal velocity would be shorter, yet the terminal velocity has only to do with the drag constant of the object, which is not subject to change. Thank you for listening to Dong J. Lee's Lab 2 on Physics.